There we go. Okay, we're up and rolling here. All right, so yesterday, we kind of threw it out there that if I had some sine value, I'll call it 1/2, find a cosine theta, right? And I told you could use the identities or you can use the triangles, right? And some of you are struggling with, because when the book presents this, it inserts something in here like 0 less than or equal to theta less than or equal to pi over 2, right? You're kind of like, what the crap does that mean? Okay. I got a lot of questions yesterday. Okay. Hey. Basically, it's just telling you where you're placed in the unit circle. Okay, so this, if I were to draw the unit circle out, quadrant 1, well, that's the thing of beauty right there. 0 to pi over 2 is right here, correct? So if you're in quadrant 1, things are nice and pretty. Everything's positive, right? X's and Y's. So you really don't have to worry about anything. Okay. Where is sine 1/2? Which angle measures that? See how sine is the y value? It's short, right? This is my geometry mind. Short is 1/2. What angle measures this?
30?
Yeah. Or the cosine value there. What goes with 1/2 on the unit circle? Yes, okay. Again, this is, you're going to get a quiz on this next week. You got to have this in your brain. That's in front of half of you. Okay, so our cosine value would be √3 over 2, right? So there's another way to solve these. Okay, so you have the identities. You also have the unit circle. If it's a nice, pretty number that the unit circle contains, or you can use your triangles. Okay. These can get a little bit more messy. So let's look at one of those. Okay, cosine's -2/3. This in red. Where is cosine negative? Where the x value is negative? This direction, right? So we're gonna, this is actually bounded. Oh, wait, that's not what I want to write. Backtrack. 90 to 180. Okay, so we're in here, right? What are we going to find? Oh, let's see here. Sine theta. Okay. Now, cosine cannot be negative over here, right? Because the x values are all positive, right? So when you see a negative cosine and then your boundary, start thinking in terms of a different quadrant here. Is sine going to be positive or negative? Yeah, positive, because the y values are positive, right? Okay, so So there's a triangle that would sit inside this. This is not the unit circle because the radius is not 1, but it gives you a good illustration. So adjacent over hypotenuse, we need to find the opposite. Okay. We can't use the unit circle because that's not a nice, pretty unit circle number, but we can use our triangles. So if you use the Pythagorean theorem, what's that? No, I don't. It's not important to me. Yeah, you could use an identity as well. I'll show that to you. But like I said, it doesn't matter to me. All right. Don't forget in your calculators, you have to put the negatives in parentheses if you're squaring them. Otherwise, you get the wrong answer. It'll be off by a negative. So 9 minus 4 is 5. So, and then again, when you take square roots, you usually algebraically, you'll want to put a positive or negative in front, right? But this is, we know, a positive y value, so we can eliminate those. We don't have to worry about them. Okay. So what is sine? Oop, that's not a pen. If this is root 5 over 3. Okay. So what I've done is introduce to you doing these in different quadrants. Okay. I think, yeah, number 8 on your homework was 0 to 90. The rest of them were in different quadrants. So if you want to handle this with an identity, is there an identity that relates sine and cosine? Can you find one? Right. Okay. So you can also use that identity. So I would plug cosine in. It's negative 2/3. And subtracted the sine over. Okay, what's that, 4/9, and then I'm going to subtract 1. Okay, that should be a negative. Remember your fraction subtraction. The negatives cancel out, I square root it, and I get root 5 over 3 equals sine theta. Okay, so you can see we get the same result. All right. Did I skip too many steps there? Or are you okay with that? You okay? Okay. Sean's okay. The rest of you are. Oh, awesome. I'm just kidding. Okay. So that would be the issue that I had a lot of questions on yesterday. So hopefully that clears it up. Okay. All right. There's one more identity I want to show you, and then a couple of examples where we're going to actually use these identities, which I kind of referenced yesterday, but we didn't talk about. So these can be pretty useful because it can kind of give you everything in quadrant 1. A is just an angle measure. Okay. So how many of you know off the top of your head sine negative power 4? It's what? Okay, that's the angle measure, but what's the value of this when you evaluate it? It's a pi over 4, so we know it's a root 2 over 2. Is it positive or negative? Yeah, don't hurt yourself. Okay. The nice thing is you know sine pi over 4 is root 2 over 2, right? It's positive. This identity allows us just to take that normal one we're used to using and put a negative in front of it. Okay, so it kind of changes it into something that's a little bit more friendly. Right? And if you know your unit circle, negative pi over 4 is right here. We know that sine is negative root 2 over 2.
Okay, so sine is the y?
Yeah. The x there would be cosine. Cosine's positive, right? So cosine negative pi over 4 is the same as cosine pi over 4, okay, which is root 2 over 2. And we can see that relationship right there. Right. See how these, sorry, that should be positive. Okay, let's root 2 over 2. So negative pi over 4 for sine, but they're opposite, but for cosine they're the same, and that's what these identities are kind of given to you. Yeah.
So on the other side of it, like on the left side?
Here?
Yeah, what was that? Like the radians, degree of 45 degrees, or like whatever. And 45 degrees.
Oh, what would these be?
Yeah. Like
Okay. This is pi over 4. This is 3 pi over 4.
oh, okay.
So it's 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi, 4, 5, 6, 7, and then back 8, 2 pi. You break it into quarters. Okay. But we write this one pi over 2 because it's more simplified. Yep. Okay. So useful identity there to make things a little more simple if you want. You probably won't use them very often, honestly, without effort. But like I said, it could earn you a point on the AP Calc exam last year, amazingly enough. Okay. All right. The meat and potatoes of this section or this chapter is solving trig equations. And we start out with just simple expressions and using identities to simplify them. So you might see something like this. Okay. It's a pretty messy expression at this point. Okay. But we want to simplify it if possible. Okay. There are some tips I can give you to make this easier, but you haven't seen doing this kind of thing before. You're going to have to sit and think about this sometimes. I would not find it uncommon for you to sit and look at a problem for a few minutes, thinking about different ways to solve it. Okay. And honestly, a math problem, 3 or 4 minutes of thinking is not a big deal. Okay. Many of us that have degrees in math sat at tables for 3 and 4 hours at a time thinking about one problem. Yeah. Have fun with that, right? Okay. So tip number 1, I already gave you. What can we do to cotangent? Change it to cosine over sine, right? So that would be right there. Change that to cosine x over sine x.
Wait, so is there an equal sign for one?
No, not yet. That's why I'm starting you out with expressions. Then we'll get to breaking these down with equal signs, and then we'll actually get to solving for x in like next Friday, maybe. It just takes a lot of practice. So can we simplify that? What do you think? You're shaking your head? What can I do? Those. Yep. So we end up with something that's a lot easier to deal with, right? Can I simplify it any further? Can I take out x? No, you can't. It's inside those functions. It's like locked in a gel cell. So don't try that. So we call an algebra atrocity. Okay, what if I were to tell you there's a better way to solve this problem? Would you slap your forehead and say, gosh dang it, I hate these kinds of problems? Okay, so here's tip 1. Okay, change sine and cotangent and tangent to sine and cosine. Okay. Tip number 2 is the other way to solve this problem. It's factor. Okay, so this is number 1, and we're actually going to get a different answer. Probably going to drive you nuts. Can I factor immediately? What can I take out of both of them? Sine x. It's in both terms. And what's left in here? 1, right? And what's left here? Yeah, cotangent. Okay.
So there wouldn't be 1 plus 1 because there's 2 signs, it'd just be 1.
Right, this has attached to cotangent.
Oh, okay.
Okay, so that's what's left over. Is there any other way to simplify that? I don't see it. Any other identities we can use. So which one's more simple? Probably this one. Okay, if you look at the book actually has this as cotangent squared. Right, so if I got to here and this was cotangent squared, I could use an identity to simplify it. I missed that. So let's see. Let me do another one here right out of the book. Simplify. Ooh, there's a good one. Make sure I write it down correctly this way. Let's see. Whew, what a mess. Okay, so this was tip 2. Yeah, they are. Long string of messy trig equation or trig functions, right? Is there, okay, what's tip number 1? Change to sine and cosine. Think that might help here? Yeah, probably. So I'm going to leave these two the same. What's secant? 1 over cosine. Thank you for the amendment. And cotangent is right. Okay, cosines cancel. Oh, I'd probably move it too fast. But you're right. And the sines cancel, yes. So what's our simplified version? Cosine x. A little easier to work with, right? Okay. Let's see if there are any other good ones to show you. Oh, let me show you a fraction that will be valuable. Okay. For now, they're probably your two best ones to use. I will give you one or two more. Yep. Secant x over tangent x. Okay. Anybody? How can I change those? 1 over cosine and sine over cosine. Yeah, fraction division is copy dot flip. So times and you can see I want you 1 over sine x. And what is that? Cosecant. Okay. So you're trying to get it down to 1 or 2. Okay, here we had 2, which is fine. There's 1 and there's 1. So you're trying to get these down to just one expression. Okay. These are the easier versions, so put some time into getting these ones down. Tomorrow it gets a little bit more difficult. Okay. We add a little bit more to it and an equal sign. Okay. We're good. You think you can handle those now? All right. If you can't, I'm here. Just say something. Do I need to write the homework down again? No. Okay. The rest of the hour is yours. It's got almost a half an hour, so take advantage of that. My estimation, you could probably finish your homework if you really tried.